Welcome. In this video, we are going to discuss about the confidence interval for the difference of means. In the previous videos, I think in the previous two videos, we have discussed about the inference concerning the two means for the large sample and the small sample. Now that we are going to find out the confidence interval in this case. Suppose both n1 and n2 are large. Okay. So when both n1 and n2 are large, with what statistic we find the inference, that is x1 bar minus x2 bar minus delta divided by under root sigma 1 square upon n1 plus sigma 2 square upon n2 when we know the population variance. If we do not know the population variance, with the help of what? With the help of sample variance, we perform the calculation. And what is this delta? This mu1 minus mu2 is the thing that we have taken as delta. Okay. So here, this is the thing that we know for sure. Okay. And some level of significance alpha is given, right? For each problem it is given. In practical situation, we choose this level of significance, that is our alpha. Okay. Confidence interval means on both the sides, both on left, like if this is delta is the quantity upon which we are going to find it out, both on left as well as on right we will find out something. So usually we calculate z alpha upon 2 in these kind of situations. When like equal things are to be calculated, we just calculate this quantity. Okay. So just do the calculations from here, that's it. Okay. So with which if you try to, okay, from here, if you try to keep only delta on one side and take everything else to the other side, instead of z you will have z alpha upon 2. Okay. So z alpha upon 2 multiplied with sigma 1 square upon n1 plus sigma 2 square upon n2, isn't it? Okay. So which is equal to what? X1 bar minus x2 bar minus delta. Okay. Just have this in one side. Okay. Delta would be x1 bar minus x2 bar. Take this thing z alpha upon 2 under root sigma 1 square upon n1 plus sigma 2 square upon n2. So now that you have got this mu1 minus mu2 is this quantity. Okay. But this z is the fixed value that we calculate with the help of all these things. Okay. So we try to what is the level of acceptance absolute of z bigger than z alpha upon 2, isn't it? Okay. So basically this gives us minus z alpha upon 2. Okay, uh, this is the case when we reject. In this case, what do? We reject h naught. Okay. Suppose if we need to accept h naught, then what should be the case? In this case, we should have absolute of z is smaller than this thing. Whether you include equality in either of the case, it is completely fine. So this should be the case. So basically with which only, okay, from this minus z alpha upon 2 smaller than z smaller than z alpha upon 2, you know your z value is this. Okay. So the same ideology you repeat, you will get the one specified here as the confidence interval. Okay. Suppose we are not aware of the population variance, use sample variance. Okay. Here we have a problem that says that in a random sample of 62 working class families, the mean consumption of milk per family is 1.28 liters with a standard deviation of 0.56 liters. While in a random sample of 53 middle class families, the mean consumption is 1.59 and the standard deviation is 0.68. Now that we need to construct a 95% confidence interval for the difference of means of the populations. So with which we find n1 is 62 and x1 bar is 1.28 and s1 is 0.56 and n2 is 53 and x2 bar is 1.59 and S2 is 0.68. Okay. Suppose in this problem, instead of asking the interval, suppose if you are asked to test the hypothesis, what do we do? Here, z would be x1 bar minus x2 bar minus delta divided by under root s1 square upon n1 plus s2 square upon n2. Okay, we calculate some value. Okay, and from the table we calculate that alpha upon 2, and that is 1.96. That is required whether we are testing the hypothesis or finding the confidence interval. Okay, now that what should we do? We have all these things, and here what was the case? uh, our mu1 minus mu2 will be in the interval x1 bar minus x2 bar minus r plus z alpha upon 2 multiplied with sigma 1 square upon n1 plus sigma 2 square upon n2. Okay, this was the interval. Now that we just need to substitute the values here, that is 1.28 minus 1.59 minus r plus, okay, this quantity is 1.96, and under root we do not have sigma 1 and sigma 2 information, so we just make use of s1 and s2, that is 0.56 square upon 62 plus 0.68 square upon 53. And when you just calculate all these things, you would get your mu1 minus mu2 belong to minus 0.54 comma minus 0.08. So this is the confidence interval for this case. Okay, now that we are going to see the confidence interval in the case of small samples, even here what we are doing, so we will reject h naught if absolute of t is bigger than t alpha upon 2. So in the, this is equivalent that absolute of t is smaller than t alpha 2. This is the case of accepting null hypothesis. Okay, when we accept the null hypothesis only, we will look for the confidence interval. Okay, here with the usual assumptions we are going to find it out. And what was our t? Our t was x1 bar minus x2 bar minus delta divided by n1 minus 1 s1 square plus n2 minus 1 s2 square divided by n1 plus n2 minus 2. This thing is to be multiplied with 1 upon n1 plus 1 upon n2. The whole entire denominator should be in a square root, right? So this was rt. So absolute of t is smaller than this one. This means what? Minus t alpha upon 2 is smaller than t, smaller than t alpha upon 2. You have the value of this t, just substitute here. So you have two inequalities when you solve these two inequalities for this delta, because this delta is what? This is mu1 minus mu2. You just solve for it and you will get this as your confidence interval. Again here this has the parameter nu, which is n1 plus n2 minus 2. Okay, here in the problem we are given that suppose that there are two brands of cigarettes with different nicotine contents. We have taken two samples from them and data are given below. So data is basically given to us. We are asked to find out the 99% confidence interval using the true difference. Okay, so here what should we do? We will have to find out the value of t alpha upon 2 for what value of alpha? Alpha is 0.01, isn't it? So alpha upon 2 is 0.005, and the parameter is n1 plus n2 minus 2, which is 5 plus 6 minus 2, which is 9, and that value is 3.25. Now that we have found it. Okay, now what more we should do? We know this mu1 minus mu2 will be in the interval uh, okay okay mu1 minus mu2 will be in the interval x1 bar minus x2 bar minus t alpha upon 2 Okay, this is n1 minus 1 s1 square plus n2 minus 1 s2 square divided by n1 plus n2 minus 2 multiplied with 1 upon n1 plus 1 upon n2 whole to the power 1 upon 2 minus, instead of this minus we would have plus, and everything else is the same. So this is the confidence interval. Now then what should you do? You have this t alpha upon 2. Now calculate this value. This n1 minus 1 is 4 multiplied with 0.12 square plus 5 into 0.14 square divided by n1 plus n2, which is 11, minus 2 is 9, multiplied with 1 upon 5 plus 1 upon 6. You try to calculate this value, supposing this as u. Okay, now that you know this value as well. Okay, and x1 bar minus x2 bar, which is 2.61 minus 2.38, which would be 0. Just a minute, 0.23. Yeah, it's 0.23. So from this what should you do? It is 0.23, isn't it? So your mu1 minus mu2 would be in 0.23 minus this t alpha upon 2u comma 0.23 plus t alpha upon 2u. So this is the interval. If you just calculate it, you would get this mu1 minus mu2 would be in minus 0.0288 comma 0.4888. So just practice this problem and check this value. Thank you.